Welcome back, nerds. Today, we get to start 4.5. And we're going to start real quick with just good luck, Lady Raiders. So, and there's no traveling gentlemen in this class, but good luck, Raiders in general, I suppose. So, cool. Yeah, energy. Love it. 4.5. We're going to start by graphing some trig functions. Now, who are the trig functions that are the easiest to work with? Sine and cosine. So let's start graphing sine and cosine. Now, some of this is going to be a recall, but I don't know really how much you recall. Again, we're going to pretend like you've just never graphed them, ever. But we're going to make it super duper nice. We're going to build a graph first. So which one do you want to start with? Sine or cosine? So let's look at sine. So graphing sine. Now, it's not always the best way, and I'm going to say graphing y. I lied, I'm going to say f of x. F of x equals sine x. If you would rather, we could say f of theta. It's really common. People get goofed up with the x, but x is just a what if we're going to plug it into sine? It's a number, but it's a number that represents some amount of something. Louder? It's an angle. So whether we use theta or x, it doesn't matter. If we want to graph a function, but we have no idea what it looks like, and you guys probably do have a little idea what it looks like, and I know that, but how do you, think back to Algebra 1. If you wanted to graph a line, I don't think that anybody in here probably just looked at it and drew it. You had to make something else on your page. You made a table, right, realistically. Okay, so as we're doing this, we are going to graph sine this first time straight from a table. So we're going to make a 3-column table for this, x, and then I'm going to have just a little space for some scratch work in the middle, sine of x, and the y or the f of x that it spits out. Now, I am A-okay if you use your unit circle with these. 100% I'm okay with it. But I want nice values. What I mean by that is, I think we can agree, if I looked at the unit circle and I wanted to know for this angle theta, that's going to be in radians right now, are there any nice sine values that spit out? Is the question. And I'm going to give you a second to check your unit circle. I'll write it here. You do not have to write this, but are there nice sine values on the unit circle? And I'm going to say UC for unit circle. So that's like an open question right now. Chat with your neighbors. I'm going to give you like 45 seconds. Are there any points on the unit circle where the sine is nice and easy and convenient? You should have found 4 right off the bat. And I agree. I do agree. I think I agree. Okay, I'm going to pull back together because I've heard 2 different groups talking about it. Right now, if I have a unit circle, and I'll put one up here on the board, and I don't even have it labeled here, but that's okay. Some of these places are nice, and especially nicer than the others. I'm going to have a blank unit circle, which makes this weird. Is this a nice sine value? How come? It's root 2 over 2, and I could grab a calculator and I could do it. It's like 0.7 something, but it still sucks, right? 0.7. Yuck. Is this a nice sine value? Why? It's 0. You tell me when I get to another one that you guarantee we can all unanimously agree is nice. Sure. Right here. It's pretty decent. Why? It's 1/2. That's a graphable point. Now, is there nicer places than just 1/2? So can we all agree that 0 is like unbelievably nice? The next one that I would argue is nice is 1/2, but unbelievably nice is probably here. 1. How about here? And here? Sorry. -1. Now, a couple things I want you to observe real quick. We're only going to use 5 points, and there's 4 of them because there's 4. The 5th comes from 0 and 2 pi being the same value. Now, I'm only going to really truly require 4 points, and we're going to tie this back together with the period and the domain and the sign of all these things. But let's use those 4 points with the understanding that I'm going to use Matilda's also. Do you guys remember what other sine value I'm going to put on this one? We won't normally. That's just kind of nice. 1/2. So let's work this out. Out of without looking, can you guys tell me the period of sine? Ooh, I heard 2 pi, and you said, what do you mean? How far, when we look at the graph, how far do we have to go until we can pick it up and set the whole graph back down? Till we get all the same values. And we'll see it here. If you don't know that, that's okay. Don't stress. Give me the first angle in radians that you want me to plug in, the first nice value. 0. So if we did this, this would be the sine of 0. And we're in radians. What's the sine of 0? 0. Okay. Now, I'm going to leave a little tiny gap here. I don't really care if you put this point in there because we won't normally. But I'm going to jump to the next super duper nice point. It was at pi over something. Pi halves is the next super duper nice point. Notice there's a small gap that if I want to put pi sixth, I can. What's the sine of pi halves? It's 1. Real quickly, just to check, can we all point? Imagine there's a big circle in front of you where this is your positive x-axis. Point to pi halves. This one's for you. All right. What's the sign here? 1. Hey, that's an easy point. Where's the next nice spot? Pi. What's the sign of pi? 0. And I'm only going to write one more here, like for sure, that I want you guys to all have. The next spot. And what is the sign of 3 pi halves? Okay, so first question that I have for you guys. Was that crazy hard? No. Anybody like want to cry and you think that, oh my gosh, that was the worst thing I've done today? You might, and it's okay if that's true. I hope it's not, but it might be. Can we plot these points? So this is going to be strange. We're going to do this like we've never done it before. I'm going to draw here, but I need way more x-axis than I need y-axis. And the scale, we are going to be kind of specific with it, but we don't have to go like absolutely bonkers with it. We're only going to graph one little part of it right now. How high up is sine ever going to be? What's the highest value of sine, whether it's on this table or not? 1. It happens to be on this table. So it means on the scale that I've chosen, I need to be able to see at least up to 1. What's the smallest y value we're ever going to get to? So here it is. We have x and we have y. Okay, this next one is the most counterintuitive thing that we've done. We're going to put radians along the x-axis. It's like we're unrolling a circle, and I'll show you some gifs of what I mean by that, because 100% it is what we're doing. But let's just plot some points. What's the furthest x value that I need based on my table? What's the biggest x value on my table? And do we always stop there, or do we always go a little bit further? Is there a natural one step further that we might go? Does it seem believable that 2 pi is going to be the next logical step? So without having to make my scale super ugly, I'm just going to look at whatever I've drawn, and I'm going to put 2 pi pretty far to the right. What's exactly between 0 and 2 pi that's going to go right here? Pi. And then I'm going to put these dashes for some other values, but I'm not going to write them because it's just going to make this super duper muddled. Okay. Anything super duper crazy happened here yet? Can we plot these 4 points? And honestly, we could go one more if we want. 2 pi, without doing the middle, can you tell me what the sign of 2 pi is? 0. Since I have it on here, I might as well look at it. And maybe I should have done that initially, so we'll say 5 points, but we'll clean this up. Can I plot these points? Okay, do not connect them yet, but I want you guys to plot them as well. But I noticed something awesome happens, and I'm going to let you guys do the same, and then you're going to plot them, I'm going to plot them, and we'll hopefully have the same, at least, points to begin with. Okay, I'm going to do something that I don't think is right, but I want you guys to tell me why it's not right. I have these 5 points. You guys do have a little bit of memory, and without just saying it, do you remember kind of what sine looks like? Okay, but if you didn't, is it possible that somebody looks at this and goes, do not draw this? I just want to stress, do not. Somebody looks at this and goes, aha, yeah, it's this. You don't think that's possible that somebody would do that? I think it's really possible that somebody would do this, right? Like we're just joining these points. What don't you like about it, Karina? It's too pointy. Well, there's only 5 points. All right. So this is, yeah, right? Cool. Okay. Now, this one, it is too pointy. I agree with you. Now, I do not ever suggest that you should add these every time, but if I wanted to, and I'm going to, I don't think you should. Could I add the pi 6 that Matilda had spotted earlier? So pi 6, what's the sign of pi 6? 1/2. And I could do, let's see, 5 pi 6. And it's 1/2 again. And I could go around the unit circle and I could get those extra points if I wanted. Now, pi 6 is about right here. And if I put a 1/2 about right there, and the other one would be about here, and the other ones would be negative 1/2, and they'd be about here and about here. If we had included those initially, does it take away my super pointy, dumb-looking sine graph and replace it with what we all expect should be the graph of sine? Now, it's not a sharp turning thing that's going on. It's a smooth curve when we graph this. So, big moment here. This shouldn't come as a shock, I don't think. But I think that if we were to graph sine for one full circle, it looks like this. Is this kind of what you remember sine looking like? Now, there are so many different ways that we can extend this question, and we're going to. If I pick this up and put it down, will I get another exact copy of this? So the smallest place that I can do that is just this part of the graph. And what I mean by that, and it's really nice when we can actually see it, disregard the letters and stuff that are here, but check it out. Here it is. I could physically pick this up and I can move it this distance away. And does it just naturally continue on? And it'll happen again and again. What's the smallest length that we just did this with? 2 pi. And this is back to the question that I got a lot of blank looks for before. We're going to denote some things here. What we see on this graph is the same question that I asked earlier. The smallest piece that I can pick up, and it just repeats everything, is known as the period. You guys just told me the period of sine just a minute ago. It is 2 pi. What is the domain of this function? All reals. Now, I only graphed one period of it, but it would keep going forever and ever, left and right. What is the range of this lovely function? I'm going to let people catch up because I can see you writing. I'm so excited about it. So I love the numbers, hate the order. -1 to 1. Brackets or parentheses? Why? X is in the interval. Why brackets? Sorry, it's not X anymore, is it? What's the range? The Y values, or the F of X, but we can call it Y. Y is in the closed interval from -1 to 1. Why closed or brackets? We include it down here. Okay, last little piece that I just want to look at. I want us to think and make a quick observation, and I'm like alluding to stuff that we're going to see and really focus on for our next class. But I want to notice something. What's the period again? And if I were to look at these, if I had a line and I wanted to cut it into 5 equal-sized pieces, what would I divide by? Like on this one, I had a length of 2 pi, right? From 0 to 2 pi is the whole length that I just traveled from this x to this x. How many cuts do we have to make to get these 1, 2, 3, 4, 5 points? 4. There'd be a cut here. 1, 2, 3, and 4. Like I can cut something into 5 equal pieces by dividing it by 4. And that's a counterintuitive idea, but I can see it happens. 4 slices cuts this up. Now, here's another really important thing that we're going to use next week when we really get into these. If we were to take the period 2 pi, and you don't have to write this down, I just want to think about this, and we cut it into 4 equal pieces, how big would each piece be? Not 1/2. Pi halves. Can we all agree that like that's not a crazy calculation? What did I jump by between each value here? And if I made the period bigger, but I still wanted to do this, could I cut it and just divide it by 4 and just jump by a different number? If this graph was not unreasonably hard, which I hope it wasn't, then literally no graph that we do with these is going to be unreasonably hard. There is a so easy way to do this. Okay, over the weekend, I want you to finish the assignment if you haven't. The good news is you have a solid 30 minutes from the time school gets out at 2:15 until you come to chess club at 2:45 to work on the assignment or to come get help on the assignment. If you're struggling with this stuff last night, come talk to me. Like, I'll help you. We can look at it. I'm cool with it. Otherwise, you guys have a wonderful weekend. Cool.